So here we are with example 2 now. And again, we just go all the way back to section 7.1 now. Well, here is a word problem. You create your system of equations, and then now we're at the point where we can solve those systems of equations. So it says Ava and Ethan sold flower bulbs for a school fundraiser. Ava sold 5 bags of tulips and 2 bags of daffodils. She raised $80. Ethan sold 1 bag of tulips, 4 bags of daffodils, and raised $70. What's the cost of each bag, or cost of a bag of each type of bulb? So first step with these word problems is we need to make some kind of let statement, or make sure that we understand what variables are going to be what. We don't have to graph this, so I don't have to be worried about x's and y's, but I'm going to say that tulips, a bag of tulips is going to be t, and a bag of daffodils is d. Oh, look, I used lowercase letters. That's funny to me. Sorry. Now we look at the cost. So now we can generate our equations. We know that that Ava sold 5 bags of tulips. She sold 5 bags of tulips. She sold 2 bags of daffodils is equal to, what did she raise? She raised $80. Okay. So I should go back here. This isn't just tulips, this isn't a bag of tulips. This is the cost of a bag of tulips and the cost of a bag of daffodils. Because over here, 5 bags of tulips and 2 bags of daffodils cost me $80, or a total of $80. Okay. And then we look at the other fellow. The other Ethan sold 1 bag of tulips, and he sold 4 bags of daffodils, and that raised a value of $70. So there's our 2 equations. And then we have to solve them. So again, we don't have variable terms that are equal or opposite, so we can't just simply add or subtract right now. So we have to decide. I want to multiply one or both of the equations by a factor so that some terms become equal, so that we can add or subtract the equations. And there's a number of different ways you could do this. I'm going to look at the top one. I'm going to say, you know what, if I multiply this equation by a factor of 2, then this will become 4d, and when I subtract from another 4d, those will cancel. So that's exactly what I'm going to do. Okay. So when I do that, 2 times 5t, 2 times 2d, 2 times 80, that brings me to my new equations, which are 10t plus 4d equals 160. My original equation below, plus 4d equals 70. And now I'm going to subtract these. And like I said, remember that you're subtracting each term. It's the biggest source of error with these types of questions. I always put a bracket in front of this. Okay. If you wanted to, you could change those terms around right now, right away. Just change that to a minus t and a minus 4d and a negative 70. And then simply add the equations together, because you've already incorporated that minus sign. Okay, so that's another way to do that. So I'm going to go minus 10 take away t, or sorry, minus 10t take away t. That's going to give me 9t. I'm going to go minus 4d, or sorry, plus 4d minus another 4d. That's 0d plus 0d. And then I'm going to go 160 minus 70. That gives me 90. So that's 9t is equal to 90. Divide by 9. Divide by 9. T is equal to 10. So the cost of each tulip bag is $10. I go back to an original equation. It does not matter which one. And I resubstitute. I'm going to go t plus 4d is equal to 70. Substitute in 10. 10 plus 4d is equal to 70. Subtract 10. Subtract 10. 4d is equal to 60. divide by 4, divide by 4, D is equal to 15. So the cost of each daffodil bag is $15. Oops. And our tulip bags cost $10. There we go. Questions are noted at the bottom of the page. And remember, the only way that you can become proficient and become really well at manipulating, become really good at manipulating these equations to solve for variables using elimination is to practice, practice, practice.